Of course, ball is having a three-dimensional, you can say, setup. In case of slicing up a volume, usually we do not we do not make a slices of a ball. Usually we are slicing up the fruits. See, for example, oranges. Look, this is the oranges season in Pakistan. Fresh oranges. Now, slicing up these oranges in pieces with the help of knife, we can see the various slices or yummy one. Yeah, just for amusement purpose. You can notice these are the one slice. So let me see the more visible picture. So this is the one slice. Okay, one in some central slice, and this portion, you can say this portion is the thickness of slice. If I am talking about horizontal along the x-axis, so it's the center, and this one is representing, or you can say like if this is passing through the center, this is representing the dx, and here is some. Okay, let me proceed to the further. So it is just like a slices of a bread. Okay, loaf of a bread is slicing up in this formation. Okay, though these are again some slices. I have too many slices. This is okay, kiwi in slice up form. Okay, let me explain some interesting one. Okay, let's explain this one, or okay, yes, explain this one. So see, if we partition this along the x-axis, this one is the y-axis. Suppose this one is representing some kind of a curve. Okay, so from this point to this point, it is representing some height y. Okay, if we want to measure the area of this single slice, it follows the notion of circle, and we know, according to, if y is what, here y is acting a radius for this. Y is what? Radius of this circular slice, and of course the face area of this slice can be represented in form of pi y square. And what's the thickness of this slice? This one thickness of this slice along the x-axis is represented dx thickness. Okay, thickness because we are partitioning in form of too many slices, one orange, so thickness is dx. If we want to add up all the slices of oranges, what we need to do? We need to add up from 0 to the total length. Okay, so what we need to do? We need to slice up at the corner. Okay, at the corner point, this y is the, okay, so we consider some y is varying, height is varying from this point to, okay, this one is the y, this one is y is varying, height is varying from this corner to this is the 0 to x. So dx thickness, or say this one thickness is same everywhere, it's the representing dx thickness is same. So each slice can be measured with this formula. Okay, let's pause here. See, it is just okay, synthetic image of the orange. For example, we are slicing up the orange. Along the x-axis. So this is the center of the orange. Y, okay, this is the y. Y of the is representing its height. Y of height of each slice. Okay, from its here. This is the y. But at each point, value of y is varying. At, okay, let's suppose radius of this this is the radius of constant value a. Along the x-axis, if we are considering at this point, at this corner point, the slice height of slice is too less and radius is almost 0. So at the corner, exactly at the corner, so the equation of circle for two-dimensional space can be written as x with radius a can be written as x square plus y square equal to a square. Now this value of x at the corner are somehow okay. If we want to measure the value of x in this point, at this point we are talking about this slice, slice at this position, then this a radius will be subtracted from this value of x minus a whole square plus y square equal to a square. Why it is subtracted? Because if we are talking about its corner, radius is at the corner point a equal to 0, so we can write x minus a whole square plus y square equal to total radius a square. So here at this point a is 0, so we can write x minus 0 y square, so of course 0, so we can write x square plus y square equal to 0. However, if we are proceeding towards right, this direction, we notice the radius, gradually, for example, a is 10 unit. At this point a is 1, this point a is 2, this point a is 3. So x-axis will be decreased. So we need to use the minus sign here. So this at this point, for example 3, this 3 will be subtracted from the total length of the x-axis. So the net equation of a circle for the remaining portion we can conclude it in this formation. So whenever we are considering the circle, we are observing the area of a circle, we need to substitute the value of y square. This y square, y is, as I told you people here, y is varying, at each point y is varying, so radius is also varying, along the x-axis also varying, because this height of y-axis or height of each slice is varying along the x-axis from corner to the corner. So a radius is subtracted, so we need to substitute the value of y square by concluding from this equation minus x minus a square. So as we will proceed from one corner, from this corner left hand side to the right hand side, the x-axis will be decreased with increment with the variation of radius a, though y is depending, height of each slice is also varying with this regard. So we are substituting the value of y square here with this variation then equation of circle will become this form. So we can get the conclusion remark here that for substituting the value of y square, we will write a square minus x minus a whole square. Then we can determine the one slice representation. So this one slice with radius a, here at center point. Here see, for example, total length, total diameter of this slice is x-axis, then of course radius is half. So we can write x minus a plus y square equal to a square. Here x is representing this one, so half will be subtracted away. In this formation, we will sum up all the slices and get a net volume of a orange. or in case of image, for example, this is one image. It is the image, we can see the side view of image, that is representing x-axis, it's representing y-axis. However, if there are too many images, okay, we are align them in such a way then we can see there is some kind of third dimension is also, okay. Suppose one is the height, other is the, okay, length. The third one is, you can say, this is the, so it's kind of a box, so volumetric form. In case of ball, we also need to determine the volume of a ball. For this purpose, let's consider the one, okay, let's suppose half portion of a ball. In half portion of a ball, if we are observing its volumetric shape, of course lower model, and if this is in case of 3D, what we need to do, we need to follow the method of solids of revolutions. Why this is known as solids of revolutions? Because the ball, of course, on the x-axis, ball on this side, this will rotate. This will rotate on the x-axis. So here, if we want to, okay, just suppose solid though, on filling air inside of a ball, it will become circular, you can say that volumetric form. It will adopt the volumetric form. So for volumetric form, or some, let's suppose the solids, okay, solids, some solid stuff of a circular pattern. If we want to slice, again like loaf of a bread, if we want to slice up the circular pattern, slice the circular pattern, so like a slice of bread, okay, from loaf of bread. I am talking about a single slice. So what will happen here? The question is, let's suppose an example for understanding. Example, find volume of a ball with radius A. Here it is given to us the radius of a ball, that is A, and what we need to determine, we need to determine volume. According to formulae of a volume for a circular, the simple definition of a volume, okay, volume in a continuous pattern, not in a summation form, not in a discrete pattern, in a continuous pattern. That ball is, in last example 24, I told you people how n approaches to infinite value, so circular pattern sides should not be visible. So we know that a football or soccer ball is composed of certain patches, but the side of, okay, kind of a spherical pattern, almost too many n approaches to infinite, so it's a complete circular pattern. So the volume, of course, volume should have three dimensions: length into width into height. 3 dimension. This is the simple formula of volume. In case of a ball with radius A, what we need to do, we need to slice up, okay? For example, this is the upper portion of a ball. Let me make different color for the lower portion. So lower portion of a ball. So for understanding purpose, we need to slice up. Slice up. Okay, let me consider this slide. Though it's the center, or you can say radius is A value. This is the radius of a ball. So we know radius is a distance from center of the corner, from center to corner, total distance. So from this point to, from any, okay, one corner to other corner, our total length is, other corner of a ball, total length will definitely A plus A equal to 2A. So though 2A is the diameter of a ball. For getting a volume, what we need to do, we need to integrate from this, we need to sum up all the all the rectangles of a curve, lower and upper curve, and we need to add up, okay? So very important thing here, now we have range from 0 to 2A. Range, or you can say, if we want to determine integral, it is range from 0 to 2A. Or for determining integral, okay, volume, in case of integral in a continuous pattern, we will this, because what is the dV? dV is the volume of one single slice. Volume of, for example, let me talk about, this is the dV. This is our core dV. We need to integrate and sum up. This is representing the sum of dV, and it will give us the volume V. Now we have 3 dimensions. We need to require 3 dimensions. Let's consider the one slice. Of course, there is a, okay, for here we can see this is the one slice side view of this slice, side view of this slide here. This is representing its what? You can say thickness of each slice. And we know the area of this, okay, this is thickness, okay, third dimension. Area of this circular face can be represented by y square. Why? Because we are, its height, okay, height. We are talking about its height, okay. Height wise we are considering, though even it does not matter on the side axis, it will same, but we know y is acting the radius, okay, y is chaining, though it is the radius for one pattern. For example, we start from this position. At this position y equal to 0, and at this position y equal to a. So if we are considering the first at corner, there is nothing, okay, it's 0, but somewhere here, of course, it will change. Definitely it will change. Then we can say along the x-axis, okay, remember along the x-axis, we are slicing up the ball along the x-axis. So if at the corner, okay, at this position x, if a radius is 0, it is the x point. Of course, x can be 1, x can be 2 in case of variable, but here if we are considering this position somewhere there, at this point we will write the slice at this position x minus a. At corner x minus a, by substituting value of a 0, we will have x only, but at somewhere in center we will subtract a from this x, because x is propagating along the x-axis. Value of x is changing from slice to slice, because there are too many slices of a ball. So we should remember that our x axis will be considered as x minus a, because at the corner, because a is a, radius will be decreased. If we are considering this slice here, the radius of course will be subtracted from this complete length of x. So this area, of course, vertical slice, the 2 dimensions, this is the area. It represents length into width. And other thing, okay, you can say that the height whatsoever, length into height here. Length into height into width. This is the representing area, that is the length into height. Okay. So the third dimension is thickness of the one slice, thickness of the one slice. So here is the dx. Now this is the volume. Consider it as equation 1. Now in the next, of course, this summation of this, integral of this will give us a volume. So here we can write volume 0 to 2a pi y square dx. However, this is in terms of y, but we can integrate along the x-axis, partitioning along the x-axis, increment in form of x-axis. So what we need to do, we need to transform this y into x value. How we can do it? We know the basic equation of circle, x square plus y square equal to a square. However, as I told you, we are slicing up a ball from this corner, okay, to this end. So our x-axis will be considered as x minus a, because at the corner value of a is 0, at somewhere in center its value will change, so x-axis will change. Therefore, we will write this x as x minus a. So our this equation 2 becomes x minus a whole square plus y square equal to a square. Now we can substitute the value of y, okay, by considering from this equation y square a square minus y square a square minus x minus whole square, or simplifying it, x square minus a square plus 2ax. cancelled out, and we will have, this is a positive term, we can write it at first place, 2ax minus x square, it's equivalent to y square. Now substitute in this equation value of y square, so it will becomes 2ax minus x. Now see, all variables are in form of x because we are having increment, okay, slicing along the x-axis. So we transform all the values in x-axis. Now we can integrate it. 2a x square over 2 minus x square over 2 0 to 2a. So here we will have x square, okay, by substituting the value of. Here we see all the variables are in form of x, though we are slicing along the x-axis. So what we need to do, we need to transform, or we need to okay, in x-axis. So on integration we will have 2a x square over 2 minus, we consider pi as a constant, so we will have x cube over 3 0 to 2a. Now by having here, by cancelling it and by further simplifying, we will write, so by substituting the value of 2a, here we will have this a, and this a will become a cube, and here 4a cube, and from the 4a cube, okay, we will, and this, okay, by substituting the value of 2a here, four a cube minus 8a cube over 3. So further we can write 4a cube over 3, or you can say 4 pi a cube over 3 is the volume of a ball. By substituting the value of a in meter or centimeter or millimeter whatsoever, we can determine the required volume of a ball in its numeric form. Remember this method is known as method of disk. Why disk? Because we are considering the one disk from it, and by summation of all the disks we can determine the net volume of a ball. Thank you.